about recursion. So in recursion, the function call itself, and compulsorily, if you're doing the recursion, we should have some ending condition. Otherwise, your function will be keep calling itself. And that could be a problem in the call stack error because there is no way to come out of the function execution. Let's see a quick example where the recursion will be helpful and how to think while writing a recursion function. So let's say we need to create a factorial by using recursion. So first understand how the factorial will be calculated. So we have a number 4, for example. The factorial for the number 4 is 24. But how this 24 is calculated? So for this, 4 into 3 into 2 into 1. So this is how the factorial is calculated. So 2 into 1 is 2, then it will become 2, then 3 into 2 will be 6, and 6 into 4 will be 24. So this is how a simple factorial will be calculated. Let me also show you for number 5 so that the things will be much clear. So the factorial of 5 is 120. So let me make it 5 into 4 into 3 into 2 into 1. So again, it's 2, 3 into 2 will be 6, 6 into 4 will be 24, and 24 into 5 will be, yes, 120. So this is how we have also calculated the factorial of number 5. So if you have observed one behavior here, we need to go inside, and then there is a number at the end for which the factorial we know. So from there, we can again come back for the calculation. So let's try to do this with the recursion function here. Factorial. And here the parameter is number, for example. So anytime there are only two possibilities in this factorial function. So if we know the number, if you know the number is 1, so the factorial of 1 will be always 1. So you can directly written 1. But in case if it's not a number 1, if anything else, maybe 4, 5, 6, anything it could be. So what the expression we will build? So we are going to return the number into the factorial of 1 below number. Factorial of 1 number below of it. So let's see how the execution is happening for this. Let me just take a result inside a variable. And here I want to calculate the factorial of 4, for example. And let's try to also understand with a systematic diagram so that you can better understand the flow, how the function is getting executed. Before understanding the flow, remember one thing. If you are calling a function, the function execution will not complete until its return statement is there. Until its return statement is not getting executed. What I mean with that. So if I'm calling the factorial 4, okay, it's going here with number 4. So the condition is matching? No. It needs to come into the else statement. Here there is a return statement, but before return statement, I need to complete this execution. So it is saying that 4 into, and again it is calling one more function. So what I understood with this, the function that I'm calling with number 4 is not yet completed. Again, it is calling the next function and the completion of the factorial 4 function is still pending here. Let's understand with a quick diagram here. So we are calling the factorial 4 that is on the line number 11. So we are calling it, as I told you, it is going on the line number 7, and here we are building the expression called 4 into, again we are trying to calculate the factorial of 3. So this is how it's begin. And now remember one thing, the factorial 4 that we have called, the execution of that is not yet completed. It is waiting here itself for the completion of factorial 3. Okay, again, when the factorial 3 is getting calling the same function, I'm coming here with a number 3. And now again, I can't go here because it's not a number 1. I need to come into the else statement. I'll say here 3 into, and I'll say factorial of 2 now. Again, remember the completion of the function factorial 3 is not yet completed because return statement not executed yet, and it is waiting for the factorial 2. So this is how it's going deep and deep. Same happens for the factorial 2. Let's come here. Again, it will come on the else statement. It will say 2 into factorial of 1. And now when the factorial 1 function is getting called, the factorial 1, let's say here, so number is 1. So we know what's the factorial for the number 1 here. So it is returning 1. And now here I can say, after calling the factorial function 1, 2, 3, 4, on the fifth time, the factorial function is getting its complete execution. Rest all the previous function are stuck on their last line and waiting for each other output. Their execution is not yet completed. So the execution of the factorial 1 is completed and the output of that is 1. So we need to return that output back for the factorial 2 function, where it is waiting with the number 2 here, and by mentioning I want a factorial of 1. So there we need to replace the factorial, the result, whatever we are getting in this stage. So now the factorial 2 function is getting its result. What is that? It is 2 into 1 is 2. Again, it will go back to the calling function and it will give its result back. And this is how we are getting 3 into 2 now. Again, the execution of this function is completed and it is giving its result back. 3 into 2 will be 6. That is here. And now, when initially you have called factorial of 4, if you remember, so it started with 4 into factorial of 3. So now you can see the same scenario here. We are ready with the factorial 3 now. So it was 4 into factorial of 3. We are ready with this results. And here we are getting 6 in the diagram if you see here. And this 4 into 6 will be 24. And this 24 will be written back to the factorial 4 function, whoever calling it. So I missed here, I guess the calculation, it's 6 into 4, 24. So here we should get the 24 and the results is 24. Let's see the final results here. Yes, it's 24. Let me try calculating for the factorial 5. It's 120. So this is how with recursion we are solving the problem for going deep and deep with the same function. And remember, in factorial we compulsory should have one last dead condition where the execution of the function will get completed like the way we have mentioned here. And we should also have one more statement to go deep and deep, and we should have one statement which will terminate the last recursion function from where the execution will start coming back, as we have seen in the example over here. Again, I'll repeat, the first statement 20 is incorrect here. I by mistakenly placed it's 24. So hope you understood how the recursion works in this lecture. Let's talk about the call stack error. So call stack error is the maximum call stack if you are making a recursive call in JavaScript. So if you are running a JavaScript inside a Chrome or maybe Mozilla Firefox, or you're trying to run under the Node.js, so it depends on the size is being allocated for the call stack from the respective environment or the platform. So in around 10,000 call stack will be provided in the Chrome browser. We'll also see the exact number which is currently I am using, how much call stack is allowed when you are making a recursive call. So we should be aware of this limit of the call stack if you are building any complex application, because your recursion should not go beyond the allocated call stack. Let's quickly understand with an example. So we'll simply try to create the factorial one and understand the maximum call stack error in that. So generally we want to calculate the factorial here of number 4, for example. And here there are only two possibilities for the factorial calculation. Number, if it's 1, then sounds good. We'll directly return the 1 here. If it's not number 1, so we need to perform the further calculation, which is number into the factorial, num minus 1. So in this way, we are calculating the factorial here. So let me execute it. We should get the 24. Let me come back to the 5 here. It should give me 120. Yes. Let me make it 4 now. So how the execution is happening here? So firstly, it is going 4 here, then it is 4 into 3, then it is 3 into 2 factorial, then 2 into factorial of 1, and the factorial of 1 is available. Then it will again start it coming back from its executing the last functions. So this statement, this particular line of statements are used to go deeper, and this statement is going to end the last the last deepest function, we can say. But let's see if by mistake we are doing some mistake here. We are not giving this minus 1. What will happen? So this is factorial of 4. So it will go 4 into factorial of 4. Again, it will call the same function and it will say 4 into factorial of 4 again. So there is no end for this recursion in this case due to the small mistake that we are doing here of not including the minus 1. Let's see it diagrammatically how this problem is coming. So I'm trying to call the factorial of 4. Then what's happening? 4 into, again it's going for factorial 4. Again 4 into factorial of 4 is happening, and this is keep happening here. And we don't have any way to stop this particular call stack here. When we can stop the call stack? When the line number 5 will get executed. But there is no way to execute. Always we are giving the same number over here due to the mistake we are giving on the line number 7. So how many calls can be done in this way? That depends on the platform. And now if I run this program and see the outcome, we should get some error here. Yes, of course we are getting the error, and that's a range error. It is saying maximum call stack size exceeded. So what if the Chrome is allocating you the call stack for your JavaScript code that you are exceeding? So let's try to understand what is the call stack size Chrome is providing you so that we can aware with this problem. Right now it's a programmatic mistake, but sometimes it could be a genuine one. For example, I'm correcting the code here, no problem. Okay, but if it's saying, but we want to calculate the factorial of a very big number, for example, like this. But if your recursion won't support to go that much deeper, so you cannot even calculate the factorial for this much bigger number. So you should be aware with the maximum call stack provided by the platform. So in this case, what we will do, we'll keep this error as it is. And here we'll just try to say a count, which is equals to 1, for example. And here we will console count, and we'll keep incrementing this counter every time we are calling it. So what's happening here? We are having a simple counter variable which is available on the global scope, and we are just consoling it and incrementing it every time my factorial is getting called. So let's see what's the count we'll get now. Program is getting crash, but before that we are getting a number called 9191. So this is a call stack size that is being provided by the Chrome browser to me. This will be different in the Mozilla. This will be different in the Safari browser if you try, because it depends on the platform which is allocating you the memory for your call stack. For me, it is 9191. So this we are able to identify by writing some extra code in existing function which is creating some problem. But you can also create a separate function to calculate this, and accordingly you can build your program. So what I can do, let me just comment out this code here, and I'll again write some more code here. Let's say the count is 1, and here I'll say a function. This is specifically we are designing so that our program should not crash and we should get to know the call stack. So if what I'll do, I'll try creating a try catch block here, because if any crash happens due to the call stack, then we'll return 1. Otherwise, what we will do, we'll keep returning 1 plus, again, we'll call the same function. So what's happening here? So every time we are calling the test function, every time we are calling a test function here, it is going here, then there is no way to stop the recursion here. You can see directly it is going on line number 20. So it's saying 1 plus, again it's calling the same, again 1 plus, it's calling the same number. So in background, what's happening? 1 plus, it is saying test. Again, this is the previous one. Again, for this test also, the same thing is happening. Again, for this test also, the same thing will keep repeating like this. So there is no aid for that, but we have very systematically tried writing one try catch block here. So let's say there is some problem in the call stack at some moment. Right now 9119, the number we got, let's say after a certain point it will fail, right? So that's the reason I have written here a try catch block. So in that case, it will fail on the line number 20, and I'll able to get to know the call stack size is exceeded now. In that case, what I'm doing, I'm returning 1. So you can understand, if my call stack size is 4, for example, so 4, and when I'm calling it fifth time, so what will happen? It will maybe the 5 is my call stack 1, and when it is failing at the last moment, so what will happen? It will go into the catch block, and here this function will not call again 1 plus test, it will return 1. And now this expression will be completed, and if you make a calculation of this 111, it is 5. I'll get to know my call stack size is 5. So the same way we have done here. At the end, the test function will return you the call stack size provided by your browser to you. Let's see the output. Yes, it's 9191. So again, also try to give some parameters, because let's also test the call stack size. Is like it change anything when we add some parameter or something to make it more heavy loaded function. So let me just write here a test here and give some parameter, and again give some parameter over here as well, and let's check. No, it's again 9191. So this is how overall the recursion works, and in that there is a possibility of call stack error. And if you want to avoid that, there are two things. One is you should able to identify what is a call stack provided by your platform on which your code is getting executed. And secondly, with that number, you should keep your code safe and you should not go beyond that call stack. So in this case, where we are calculating the factorial, what we can do, if the number is greater than equals to 9119, which the number we have got, I guess it was, no, 9191, right? 9191. So here I'll return directly -1. And with that, I'll also give a message: factorial calculation is available only till 9190, for example. So I'm informing my user, you're not allowed to go beyond this number. I'm capable of only performing the calculation till this level. Of course, to solve this problem, there could be some alternatives, but here is a restriction in this case due to the call stack error. And now if I try to call this function by giving a very big number like this, let me console the below code, and if I see the outcome here, immediately I'll get the error here, like factorial calculation is not available beyond this number, and it is returning me -1. So at least the user is getting to know, maybe, or maybe we are getting to know, and the program is not getting crash. So this is how the call stack error works in detail.